It's 2 a.m., and you're lying in bed with your phone 6 inches from your face, scrolling through a feed of people who are, at this exact second, apparently having a way better night than you. Nobody's texted back in 4 hours. The apartment is quiet in that specific way that makes quiet feel loud. And somewhere under your ribs, there's this ache. Not sadness exactly. Something tighter than that. Something that if you had to point to it, you'd point at your chest. Not your head, like the feeling has an actual physical address. Here's the wild part. You're right, it does. That ache isn't a metaphor. It isn't your brain being dramatic or just anxiety or some poetic way of describing sadness. It is biologically, chemically, measurably the same signal your body sends you when you are physically injured. Your nervous system does not appear to keep a separate file for heartbroken and actually hurt. As far as your oldest wiring is concerned, they're the same emergency.
Which should honestly bother you more than it does. Physical pain makes sense. Touch a hot stove, feel pain, pull your hand back, don't die. Clean, obvious, useful. But loneliness? Sitting alone in a room or unanswered on a phone doesn't burn you, cut you, or break a bone. So why does your body respond like it does? Hold on to that question, because the answer is older than language, stranger than it's just an emotion. And by the end of this video, that 2 a.m. ache in your chest is going to look like something completely different to you than it does right now. Let's actually define the problem first, because loneliness hurts is one of those phrases everyone nods along to without ever really examining. We say heartbroken. We say that text stung. We say someone was gutted by a breakup. Every language does some version of this, describing rejection. And
then, in the early 2000s, a social psychologist at UCLA named Naomi Eisenberger decided to stop assuming and actually check. Here's what nobody tells you about how she checked. She put people in an fMRI machine, alone, wearing a headset, and had them play a simple video game called Cyberball. In Cyberball, you toss a virtual ball back and forth with 2 other players on screen. The participants were told the other 2 were real people playing online. They weren't. They were a script. And at a certain point in the game, the script would simply stop passing the ball to the participant. No explanation, no insult, just silence, and a ball going back and forth between 2 other players while you sit there, left out, for the rest of the game. That's it. That's the entire manipulation. No insults, no confrontation, no real stakes of any kind. Being excluded from a pointless game with strangers you'll never meet for less than 10 minutes by 2 icons on a screen that aren't even controlled by real people.
Think about how flimsy that setup is supposed to be. This isn't a betrayal by a spouse. It isn't losing a job or a friend cutting you off or anything your rational brain would call a genuine threat. It's a ball not being thrown to you in a video game. And yet, afterward, when researchers interviewed participants, people reported real, measurable distress, feeling excluded, meaningless, rejected, sometimes even angry over an interaction that, on paper, cost them nothing. And when Eisenberger's team looked at the brain scans, 2 regions lit up during that exclusion in a way that tightly correlated with how much distress people reported feeling distress: the dorsal anterior cingulate cortex and the anterior insula. Hold on to those 2 names, because they matter for a reason that has nothing to do with jargon. Those exact same 2 regions are part of what pain researchers call the brain's pain matrix, the network that activates when you're in physical pain. Not similar regions, not a pain-adjacent network. The same core circuitry that lights up when you stub your toe or burn your hand lit up when a stranger stopped throwing you a fake ball in a video game.
The study went up in the journal Science in 2003, and the title was almost deliberately blunt. Does rejection hurt? The paper argued yes, not figuratively, but at the level of shared neural architecture. Being frozen out by 2 people you'd never met and would never meet produced a brain response overlapping with actual tissue damage. Sit with that for a second, because most people hear this fact and immediately move on to the next one. Don't. A video game a child could learn in 15 seconds, played with strangers, for a few minutes, produced a measurable pain signature. Not a mood, not a vague discomfort, a pain signature. Except that's not even the strangest part of what her lab found next. If exclusion activates a pain response, the obvious follow-up question is almost too obvious to ask out loud. Could you treat it like pain?
As in, with an actual painkiller?
A researcher named Naomi's collaborator, C. Nathan DeWall, ran exactly that test a few years later. Participants took either a placebo or 2,000 milligrams of Tylenol daily for 3 straight weeks, just regular over-the-counter acetaminophen. Then, at the end of the 3 weeks, everyone played Cyberball in the scanner and got excluded the same way Eisenberger's original subjects did. The people who'd been taking Tylenol showed significantly less activity in the dorsal anterior cingulate cortex and the anterior insula during exclusion than the people on placebo. The people on the physical painkiller reported feeling less hurt by social rejection. A drug you'd take for a headache or a sprained ankle dulled the sting of being left out of a game with strangers. Read that again, because it's one of the strangest findings in modern psychology, and it barely gets talked about outside academic circles. A physical painkiller acted as a social painkiller. Not because Tylenol has some special emotional ingredient, because as far as your brain's pain processing machinery is concerned, there may not be as clean a line between social hurt and physical hurt as we assume.
Now, here's where I need you to slow down with me, because this is usually the part where a video like this just says, "See, loneliness is literally pain," and moves on to the next flashy fact. That's not the full story, and skipping the next part would make you dumber about this topic, not smarter. Because in 2013, a much larger analysis pushed back hard on the simple version of this claim. A team led by Chung-Won Wu pooled data across multiple Cyberball neuroimaging studies, 244 participants combined, and ran a more rigorous statistical technique than the earlier single lab studies had used. Their finding complicated the tidy story. The dorsal anterior cingulate cortex activation seen during social rejection didn't reliably match the exact physical pain matrix signature once you controlled more carefully for what's called expectancy violation, basically surprise and rule breaking, rather than pain specifically. Some of what looked like pain in the original studies may have partly been the brain reacting to an unexpected, unfair situation, not pain in the strict clinical sense.
So which is it? Is social rejection literally processed as physical pain? Or is that an oversimplified headline that outran the actual data? The honest answer, the one most serious researchers in this field now hold, is somewhere in the messy middle. The overlap between social and physical pain circuitry is real, replicated across multiple independent labs, and the Tylenol effect has been reproduced. But it isn't a perfect one-to-one identity. Your brain isn't confused into thinking a breakup is a broken leg. It's more like these two systems, the one that detects bodily threat and the one that detects social threat, evolved by borrowing each other's wiring because they were solving a similar underlying problem at different points in your evolutionary history. Not identical twins, more like two systems that grew up sharing a bedroom. And that reframe, shared wiring for a shared underlying problem, is actually the door that leads to the real answer to our original question. Because once you stop asking, is loneliness literally pain, and start asking, why would evolution build overlapping alarm systems for physical injury and social exclusion in the first place, you're no longer looking at a neuroscience curiosity. You're looking at a 5 million-year-old survival strategy.
Here's a detail that rarely makes it into pop psychology explanations of this topic. And it should, because it's the missing piece. This overlap between physical and social pain isn't unique to humans. Researchers studying non-human primates have found that damage to the dorsal and ventral anterior cingulate cortex reduces distress vocalizations when infant animals are separated from their caregivers or their social group. Stimulate those same regions, and distress calls increase. That's not a human quirk layered on top of an older mammalian brain. That circuitry and its job of screaming, "Get back to the group," predates us. It predates language. It may predate our entire genus. Which brings us to the man who spent the last 2 decades of his career arguing that loneliness isn't a bug in human design. It's a feature, deliberately built in, on purpose. His name was John Cacioppo, a social neuroscientist at the University of Chicago. And starting in the early 2000s, he laid out what's now called the evolutionary theory of loneliness. His core argument goes like this. You already accept, without question, that hunger is a signal telling you to eat, and that fear is a signal telling you to get away from danger. Nobody thinks hunger is a flaw in human design just because it's uncomfortable. It's uncomfortable on purpose, because discomfort is what makes you act.
Cacioppo's argument was that loneliness works exactly the same way. It's not sadness that happened to attach itself to isolation by coincidence. It's a dedicated, evolved alarm, as biologically real and as old as hunger or thirst, whose entire job is to make being socially disconnected feel unbearable enough that you do something about it. And here's why that alarm needed to be so loud specifically for our species. For the vast majority of human evolutionary history, being cut off from your group wasn't an inconvenience. It was closer to a death sentence. No claws, no real speed, no natural armor. You've probably heard some version of that list before, because it's true. And it's the entire reason cooperative, coordinated group living became our species' one real defense against everything. A human alone on the savannah 2 million years ago, cut off from the group's collective vigilance, its shared food, its combined defense, wasn't just sad. He was exposed. Vulnerable to exactly the kind of predation the fossil record has documented again and again. In skulls with puncture wounds that match a leopard's lower canine spacing. In remains bearing the marks of a bird of prey. A lone human at dusk, with no one else's eyes scanning the grass alongside his own, was not a tragic figure. He was, statistically, a meal waiting to happen. Now, picture the alternative. A member of that same group, drifting slightly toward the edge of camp, distracted, distant, not quite bonded in. If nothing intervened, nothing corrected it, that drift could end the same way. But something did intervene. A feeling. Sharp, uncomfortable, impossible to ignore, rising specifically at the moment the distance from the group started to grow. Not guilt, not sadness, something closer to an internal siren. And the siren worked. It pulled that person back toward the fire, back into the group's collective vigilance, back inside the one thing standing between them and the exact fate written into the fossil record. Multiply that single correction across tens of thousands of generations, and you're not looking at an emotional quirk anymore. You're looking at one of the most quietly load-bearing survival tools your species ever built. So think about what that means for natural selection. Somewhere back across those millions of years, two kinds of early humans existed side by side. One kind barely registered social disconnection. Drifting from the group didn't bother them much. The other kind felt it acutely, an intense, specific discomfort the moment they sensed themselves slipping toward the edges of the group or being excluded from it. Which of those two temperaments is more likely to have survived long enough to pass on their genes?
The ones who felt it. The ones for whom being alone triggered something close to alarm, and who acted on that alarm by closing the distance, repairing the bond, getting back inside the circle of protection before nightfall. Generation after generation, that discomfort got selected for, refined, wired deeper, until it became a fixed feature of being human, not a personality trait some people happen to have, a baseline circuit installed in essentially everyone, the same way hunger is installed in essentially everyone. Here's the detail that should genuinely surprise you, because it explains something you've probably noticed about people without ever having language for it. Loneliness sensitivity is heritable. Researchers estimate somewhere around half of the variation in how strongly people feel it traces back to genetics, similar in magnitude to traits like height. And Cacioppo's collaborators have pointed out something clever about that variation. If intense loneliness sensitivity were purely bad for survival, evolution would have quietly bred it out over enough generations, the same way it eliminates most traits that are pure liabilities. It didn't, which suggests the variation itself was useful. Some early humans, less sensitive to isolation, were freer to range out from the group.
scouting new territory, tracking distant game, taking the kind of individual risks a more anxiously bonded person wouldn't take. Others, highly sensitive to any drift from the group, functioned as the social glue holding the whole unit together, noticing fractures before they became fatal ones. A tribe made entirely of fearless wanderers would have scattered and died alone. A tribe made entirely of anxious homebodies might never have found new territory or resources at all. The mix is what worked. Which means that ache you feel isn't a flaw in your particular wiring. It's your specific setting on a survival dial that's been calibrated across millions of years of trial and error.
Now, think about the last time you felt that specific, oddly sharp discomfort. Not after a real crisis, just after being left on red for a few hours, or noticing you weren't included in a group chat, or walking into a room where people stopped talking. You probably know that feeling is a little disproportionate to the actual stakes. Rationally, being left on red for 3 hours changes nothing about your physical safety, and yet the alarm goes off anyway, sharp and immediate, like something in you is checking whether the group is still there. Maybe you replayed the conversation, looking for what you said wrong. Maybe you told yourself you were being irrational and felt the ache anyway, completely unmoved by your own reasoning. That gap, knowing intellectually that nothing is actually wrong while some older, faster part of you insists that something is one of the most common and least understood experiences of modern life. And it makes a lot more sense once you know it isn't a personality problem. It's a mismatch between the speed of your reasoning brain and the speed of a much older alarm that doesn't wait for permission to fire.
That's not you being oversensitive. That's the system working exactly as designed. Researchers studying loneliness have found that people experiencing it tend to become hypervigilant to social threat, quicker to notice signs of rejection, quicker to interpret ambiguous situations as exclusion, quicker to brace for disappointment. In an ancestral environment, that hypervigilance made sense as a protective feature. If you drifted from the group once, you couldn't afford to misjudge who was safe to reconnect with, because trusting the wrong person could be as dangerous as staying isolated. The catch is that same hypervigilance in a modern context can make lonely people read hostility or disinterest into completely neutral situations, which pushes them to withdraw further, which deepens the very isolation the alarm was trying to fix in the first place. The exact mechanism built to save you can, in the wrong conditions, start working against you. Here's another piece of this that almost nobody connects to the rest of it. For nearly all of human history, connection wasn't abstract, it was physical. Grooming, sitting shoulder to shoulder around a fire, a hand on your arm, proximity you could feel on your skin. Some anthropologists argue that language itself evolved partly as a more efficient substitute for physical grooming, once our groups got too large for everyone to groom everyone the old-fashioned way, a way of maintaining the bond at scale, with words standing in for touch. Which means the connection your alarm system is actually built to register was never just information. It was presence, a voice in the room, a body near your body.
A text that says, "Hey, miss you," gives your brain a small amount of that signal. It is not nothing, but it is a thin, compressed, low-resolution version of what the system evolved to expect. The same way a photo of food gives you a little dopamine, but doesn't actually make you less hungry. You can have 500 people who like your post and still feel the alarm ringing, because liking a post was never the currency this system was built to accept. And that mismatch, an ancient alarm meeting a completely unrecognizable modern environment, is where this whole story stops being a neat historical fact and starts being about your actual current life. Because your loneliness circuitry wasn't calibrated for a species of 8 billion people, most of whom you'll never meet. It was calibrated for a tribe. Researchers estimate the natural size of a human social group we're built to meaningfully track and bond with sits somewhere around 150 people. A real face, a real relationship, a real stake in each other's survival. Your ancestors' alarm system had exactly one job: Monitor your standing inside that tight, physically present, mutually dependent group of maybe a few dozen to a couple hundred people, and scream if you drifted from it.
Now look at what you're actually asking that same ancient system to process today. Hundreds of friends you've never had a real conversation with. A feed of strangers whose highlight reels your brain half registers as social information, the same way it would once have registered actual tribe members. Messages that arrive instantly and can be left unanswered indefinitely, which your ancient alarm system reads less like they're busy and more like the group has gone silent. Because for most of human history, silence from your people meant something was very wrong. You are running Ice Age software, issuing Ice Age alerts. Except now it's trying to interpret a world of 500 acquaintances and 0 real tribe. And it genuinely does not know what to do with that. It keeps ringing anyway, constantly, in the background, at 2 a.m., over a text that never came. Which brings us to the part of this that stops being an interesting evolutionary footnote and becomes something with real, measurable stakes for you specifically.
Because an alarm that never gets properly answered doesn't just switch off after a while. It stays on. And a stress response that stays on, chronically, doesn't just live in your mood. It shows up in your body. Researchers who study the biology of chronic loneliness have consistently found it associated with elevated levels of stress hormones like cortisol, disrupted sleep architecture, and changes in immune function, including markers of low-grade inflammation that, over years, quietly wear down the cardiovascular system. Social neuroscientists at UCLA studying gene expression in chronically lonely people have even found shifts in how certain immune-related genes get switched on and off, the kind of change you'd expect to see in a body that's been bracing for a threat that never fully resolves. Your ancestors' version of this alarm was meant to be answered within days by rejoining the group. Yours can stay switched on for years, quietly, in the background, answered by nothing. If this is the kind of question you didn't know you needed answered, subscribe to the Human Ledger. The next one is more unsettling than this one.